All right, our team, here is your demonstration video for Module 2, which is a review of linear regression. So first thing I'm going to do is I'm going to navigate down here in the File menu to the place where my file, my data set is. So for me, that's in Multilevel Modeling, and then my weekly materials, and then week 2. So here, this might be in your downloads or your desktop. This was the data set that was available for download on Canvas, along with the demonstration video and the handout. So it's called food.csv. And you'll notice the Schroeder et al. Article that's assigned for this week. That's a review of linear regression. This is the same data set that they reference in Schroeder et al., looking at the relationship between family income, what you spend on food, and some other variables. So it's a very sort of simple, straightforward data set to help us think about how linear regression works. So one thing I'm going to do, so this is sort of the screen you get when you open up RStudio. I'm going to get myself an R notebook going here, and I'm going to get rid of all this extra stuff and just kind of work on my own. So the first thing I'm going to do is import this data set, and here I'm going to make a little R chunk here because I want to be able to do this later. So I'm going to click on this food data set, and I'm going to say import, and I get this nice window here, and I'm going to change the name of the object to just food. I want to just call this food, and that's going to be the name of the data set once it's read into R. And so here we get a nice preview of the data set itself. We have 4 variables. We have food consumption, family income, the number of children. That's spelled wrong. We can fix that. I can show you how to do that. And then whether or not you have a garden. And notice this says double, double, double. So these are numeric values, or at least R is recognizing them as numeric values. And then this have garden is character. So these are words, yes or no. So what you can do is you can do a couple things. One, you can just click import, and it will automatically load this into RStudio for you, which is really cool. And then notice in our environment we now have a data set called food, which is made up of 51 observations of 4 variables. And then we get built in automatically, the view command is also ran. And so by clicking view, you actually get a look at that data set. You can also do that just by clicking on it like this. It'll open it right up, and you can get a look at it. And notice a funny thing down here. Person number 51 down here at the bottom is all NAs. And NA is R code for missing. So, this happens a lot when you input files of different types. This is just sort of an error in the reading. So I would want to double check and make sure it is actually an error, but I'll show you how to get rid of that a little bit later. All right, so just to recap, so what I like to do, well, first of all, I should load in a few handy libraries. So a few libraries that we're going to use all the time. Tidyverse. So make sure we load that one in. And we get some responses. And I'm trying to think if we need any other ones. We might need the ggplot package, which I showed you last week. So I can just type that in. And that's called ggplot2. And then let's see, the broom package is a really nice one for cleaning up models and putting them all together. I don't know if we'll actually use it here, but we will definitely use a version of it when we use multi-level models. And then the SkimR package is another really nice one for creating summary pages of like little mini code books for your data sets, and that can be very handy too. So we'll load all 4 of those. And notice as I was typing those, each time I pressed Control Return, And when you press Control Return, that's just a shortcut for running that one line of code. You can also run this whole chunk of code if you go up here and push the play button, but we don't need to necessarily do that now. But that gives you the exact same thing. If you might get an error, like there is no package called skimr. And so if you need to install skimr, you can come right over here to Packages and click on it and give it a moment to load up what packages you have, and you probably have some that are installed already. So they're split up into the user library. These are the extra ones that are developed by R users. You can see I have a lot of these because I use R for a bunch of different things. And then below that, you'll see what's called the system library. And these are the base packages. There we go. The base packages that come pretty much with R installed. So when you install R from the website, you pretty much get these packages and maybe a few user packages. So if you need to install skimr, you just push install here and then just type skimr and it pops right up, and then you can press install. You do want to install any dependencies. Sometimes packages depend on other packages to sort of speed up the process, and you want to install all those. So you can install it, and then you can run that same command to load the package in for you. Okay, so I want to grab the code that was ran down here on my console to get this data set actually into R in case I need to do it later. And okay, so the library was read R. That is part of the tidyverse, so I don't need that library. I already have it loaded. But I do want to grab this little line of code here, and that is what was run to input my CSV file, my comma-separated variable file, and create a data set called food. And notice we get a little message here where the software is inputting, so the software thinks that the first variable was a numeric, the second was numeric, the third was numeric, and the fourth was character. And then the other command that we ran was just view, and that is, here I'll put that in a different chunk. So view food, and notice you get predictive typing, so food actually pops up when you start typing, which is really cool. And if you run that again, it will open up the data set and it'll show you what it looks like. And then I always like this command glimpse, and notice again predictive typing, it pops up, and so you press enter, so glimpse food, and this will actually pop out down here. What I like about glimpse is it's a little more compact, and it just gives you a nice record of everything you ran. So we have 51 columns, 51 rows, I'm sorry, so those are the number of observations. There's one that's all missing, we can take care of that. There are 4 columns. Here are 4 variables: food consumption, family income, number of children, and have a garden. Okay, so now let's do a little data cleaning and coding. And I'm going to show you 3 different functions in R that are really good for data cleaning and coding. And I go into much more detail on this on the handout. So if it seems like I'm going fast and you're like, oh, what was that? How does that work? Take a look at the handout, because I take a little bit more time to kind of walk through what each command is and how it works. So when I look at this data set, both looking at the glimpse and also just viewing the data set like this, I see right away the thing I'm thinking about is, what do I need to do to this data set to get it to a point where I can do statistics with it. I can do math with it. I can run models and get summary statistics. And also, how can I sort of streamline and create procedures that allow me to do this in a pretty routine way? Because if you do this a lot, it's nice to get a set of routines. So the first thing I notice, all these variable names are capital letters. And that is generally pretty crummy. I tend to prefer that all variable names are lowercase, because all statistical software is case sensitive, or most statistical software is case sensitive. Stata is case sensitive, R is case sensive, SPSS, so on and so forth. And so if you have something in all caps, it basically creates one more thing that could go wrong with your analysis, because you may forget that the variable should be all caps, and that's a problem. So I prefer to just make everything lowercase. The other thing I like to do is I like to make these variable names as readable by humans as possible. So these names are just kind of like a smushing together of several words, and they're kind of hard to read. So I like to make them words that or phrases that you can read using underscores. So I'll show you an example of that. Okay, so what I'm going to do is I am going to dedicate this chunk to cleaning and coding my data set. And so what I'm going to do, I'm going to end up at the end of this with a copy of my data set that I'm going to call food.clean. And this is a really good data management procedure. In general, once you input the raw data into your data set, it's always best not to change the raw data. And in R, this is very easy because you can make a copy of the existing data and you can clean it and code it, and then you have a second data set that you're working with and an original data set that actually shows the variables and the observations as they were from the beginning. This is a really, really important thing to do because sometimes you get stuck, you press the wrong key, things get shifted, and you really don't know how to get back to the beginning. And the nice part here is you can always look back to the beginning. So we're going to get a new data set called food.clean, and we're going to start with our original data set, food, and then we're going to use this fancy looking sign called the pipe operator. Now I know you might be thinking about this and being like, what the heck does that mean? It looks fancy, but it has a really simple meaning. All it means is then. Okay? And it's made by the percent sign and the greater than sign and the percent sign again. And notice it actually turns a special color because our studio recognizes that this is the pipe operator. So this comes from a package called Magritter, which is built into the Tidyverse, and it's designed to help you build a workflow for cleaning your variables. So what I always like to do is I rename my variables, then I create any new variables, and then I address my missing data, and then boom, I have in one command, one seamless command, I have all the cleaning and coding and renaming that needs to happen. So if I ever need to go back, it's really easy to do that. So we start with food, and then we have our pipe operator, so that means then jump to the next line. The first thing I want to do is rename those variables, and dplyr, which is the Tidyverse package for data management, has a really nice command called rename. So I'm going to rename the first part of that call is what the data is, and I can just put a decimal point here because since I'm using the pipe operator, the decimal point says just look further up the chain. So the data I'm starting with here is food. So that's a really cool part about using the pipe operator too. So rename with a decimal point, and then a comma, and then I'm going to jump to the next line, and I'm going to take this variable called food consumption, better spell it right, and I'm going to make it equal to my original variable, food consumption. And notice with predictive typing there, that purple line, it pops right up. So I have now renamed this gross, messy looking variable, food consumption, and now it's all lowercase and it's readable. And I put a comma, and I can do as many of these as I want, all in the same statement. So I'm going to rename the family income variable and make it equal to the old name. So this is just going to rewrite the name of this variable in the data set. And number of children, I'm just going to call num_children and make that equal to num children. And notice predictive typing, it didn't pop up. Why? It's actually num children. It's misspelled, right? And so there, I can just change it that way. And then have garden, just make that equal to have garden. Okay. Ta-da! Just like that, I've renamed my variables. And believe it or not, if I just run this command right now, this command will run, and I have food.clean, except food.clean has now been renamed. So there are my new variable names. So I'm not going to stop there. I'm going to keep using this pipe operator, and I'm going to do the rest of my cleaning and coding all at once. So then, bump to that next line. The next thing I want to do, so as I'm looking at this variable have garden, see how it says CHR right here? That means it's a character vector. That means that it's stored in the software as text. And unfortunately, it's really hard to do math on text. You have to convert that text into some kind of a hard-coded variable that you can work with. And so the code to do that, or the term for that in R, is called creating a factor variable. You might be familiar with that from the days of ANOVA. So you want to create a factor variable. And what a factor variable does is it looks at all the different values of a variable, and it makes each different variable its own numeric group. And so you can then do math, you can do ANOVAs, you can have dummy variables, all sorts of things once you've converted a character variable to a factor variable. So to do that, the command is mutate. Again, I press enter, it pops that in there. My data is still the same, so I can put that period in the comma and jump down. And here I can list all the things that I want to change. So mutate just means create a new variable that is a transformation or a mutation of an existing variable. So I'm going to create a new variable called have garden underscore fac, and I'm going to make that equal to as underscore factor, and this is a function, again from the tidyverse, from the package called forcats, that all it does is it just converts a variable to a factor. And so I'm going to convert this variable have underscore garden, the original one, into a factor variable. So now I'm going to have this new variable called have garden fac, which actually is a factor variable, which I can do math with. All right, and the last thing I'm going to do, again, pipe operator, which means then, I'm going to run this function called na.omit. Now, na.omit, I have a nice explanation of this in the handout. This is a use carefully function. But what this does is it removes all of the missing data for you. And in this case, the only missing data in this data set is found in observation 51, which was all missing. So this is going to drop that observation out for us. Again, this is something you do carefully. In R, most of the statistics that you do in R will give you an error if you don't address the missing data first, because it kind of assumes, okay, if you're using R, you're sort of aware that missing data is a problem and you have to do something with it. So one of the things you can do is to omit it. There are lots of other things. We talk about them in my multivariate class. But for now, we're just going to use listwise deletion, and we're going to remove that observation. Okay, so, and then I'm going to run this chunk. And sure enough, I now have food.clean. I have an extra variable, which is my factor variable for have garden. And then I'm going to take the glimpse command that I had before, and I'm going to glimpse this new data set called food.clean to see if everything has been cleaned up. So let's take a look here. And sure enough, I have now all my variables have been cleaned up. They're all in the formats they should be. And notice here have garden is now a factor variable. And it doesn't have those quotation marks, which means it's no longer just text. It's actually hard-coded text. So this is a variable that I can actually do math with, which is great. And everything else looks good. I only have 50 rows, which means my 51st observation has actually been cleaned up. So that gets me to the point where I'm in pretty good shape. And another thing I can do to run a summary, I'm going to add another chunk here. I'm going to do a skim. So skim, and I'm going to skim this food.clean data set. So this is a really nice way to summarize my data. So skim is cool. It's a package that kind of gives you a lot of information about your data set. So first of all, you get a data summary, which is this top part. So this is the name of the data set. It has 50 rows, so 50 observations. There are 5 columns. In terms of frequency, I have one character variable, which is have garden. I have one factor variable, which is have garden factor. And I have 3 numeric variables. I have no grouping variable specified. We won't get into those quite yet. Here is a summary of my character variables, which is have garden. I'm not too worried about that one. I'm not going to use it. Here is have garden factor. So this one's pretty cool. And missing. So there are none missing. 100% of these are complete. There are 2 values. Number of unique values, no and yes. And I have 36 no's and 14 yeses. So 36 people did not have a garden in this data set and 14 people did. And then here's my here are my numeric variables: food consumption, family income, and number of children. So food consumption, this is in dollars. So the mean is about $8,800 with a big standard deviation, about $4,500. So the average family spends about $8,000 or $9,000 a year on food. Here are my percentiles. Here's the lowest value. Here's the highest value, and here are the quartiles. So this is the median here, which is about 8,800. And then I get a cool, nice little histogram, which, you know, it's not the nicest histogram in the world, but it does give you a sense of the overall shape of this variable without having to run an extra command. And then here's family income. The mean family income is 72,000. Standard deviation is 54,000. And here are my quartiles, and my median is 52,000. That, of course, is very typical of family income. You have some pretty high outliers who kind of skew the mean and the direction of the maximum. And then here is number of children. The average was 2.28. The smallest was 1, and the largest was 6. So in this case, we didn't have any families who did not have kids. So we're just looking at the impact of having one child or more on food consumption. Okay, so I think this is a good place to stop. We've been going about 20 minutes. This is just a nice overview of a lot of kind of housekeeping things that you do all the time. This is not specific to multi-level modeling. This is not specific to regression. This is how to load up some packages, how to get data into R, how to look at the data set, figure out what you need to clean, and then figure out the tools that can clean it for you, and then create a summary. So I'm going to stop here, and then part 2 is going to cover actually running the regression models. So I'll talk to you in a second.